Hi everybody, Mr. Gerard here, and I wanted to take a quick moment just to kind of go through two quick examples because I know some of you are struggling with this making use of structure 2, factoring polynomials with special product forms on Khan Academy. And so what this is really going off of is this idea of special product forms, where if you have like the sum and product of the same terms, like here, a plus b, a minus b, that's a squared minus b squared. And then if you have a sum of a square of a sum or square of a difference, then we get these special product formulas. And then also if you have a cube of a sum or cube of a difference, you get these. Now you don't have to memorize these, but you should at least recognize them and see how that will help you when you come to factoring. So for example, we have a difference of squares, we have a perfect square, another perfect square. These perfect square trinomials we'll see when we do completing the square. And then you have difference of cubes and sum of cubes, which are also important to use when factoring. So when we see a special factoring problem, it's going to look something like this. Now if you look at this right away, you're like, whoa, those are some pretty big numbers, I don't know what's going on, there's an x and a y. Don't worry about it. When you look at it, you should recognize that 81 and 16 are both perfect squares. And you should also notice that x to the 20th and y to the 8th is a perfect square. So you can really think of this problem as 9x to the 10th squared minus 4y to the 4th squared. And then when you follow your difference of squares factoring formula, you should get something like this: 9x to the 10th plus 4y to the 4th times 9x to the 10th minus 4y to the 4th. Now, when you look at this factor here, notice 9x to the 10th is also a perfect square, and 4y to the 4th is also a perfect square. So we have a sum of perfect squares, which we can't factor with real numbers, and then we have a difference of perfect squares right here. So let's factor this again. And when we do that, the 9x to the 10th plus 4y to the 4th stays where it is. The 3x to the 5th plus 2y squared and the 3x to the 5th minus 2y squared are the factors of this term right here. And so those factor completely. So even though we started with a really big degree polynomial here, x to the 20th, y to the 8th, the 81 and the 16 was a huge key to knowing that it's a difference of squares. One other one that we want to look at is something like this: x to the 4th minus 18x squared plus 81. Some of you be like, man, I don't know how to do x to the 4th, like that's tricky. But look at this, x to the 4th and x squared, that's almost like x squared minus 18x plus 81. So if I look at x to the 4th minus 18x squared plus 81 as x squared minus 18x plus 81, the x squared minus 18x plus 81 factors x minus 9x minus 9. That's a special form. That's a perfect square trinomial. So this on the left is also a perfect square trinomial, and instead of x minus 9 times x minus 9, it's x squared minus 9 times x squared minus 9. We're not done yet though, because x squared and 9 are both perfect squares, and we can factor that. So the x squared minus 9 is x plus 3, x minus 3. The other x squared minus 9 is x plus 3, x minus 3. And then we can combine like terms here, or at least like factors, and simplify a little bit further and get x plus 3 squared and x minus 3 quantity squared. So I hope that helps. If you have any other questions, we'll talk about it again tomorrow and Wednesday. But I would take a look at this and see if you can get to that practice level, and then do some extra on Khan Academy.